Probability. In 9th standard we studied about empirical probability. What did we do here? We conducted experiments and we took the outcome of such experiments and calculated the probability. Let us take an example here. A coin was tossed 200 times and every time we tossed the coin, we recorded whether head came up or tail. And at the end, we noticed that 108 times the head came up and 92 times the tail came up. The empirical probability of head coming up is 108 divided by 200, that is 0.54, and tail coming up is 92 divided by 200, that is 0.46. Now these probabilities are estimates. It means now if you repeat this experiment, that is if you toss the coin another 200 times, there is no guarantee that we will get the same answer. Now here we did 200 tosses. Now if you keep increasing this number from 200, say 1000, 10,000, 1 lakh, 1 million, what we will notice is as we increase, the probability of both this value as well as this value, that is the probability of head coming up and the probability of tail coming up, both will keep moving towards half, that is 0.5. We call this as the theoretical probability of getting head or tail when we toss the coin. Theoretical probability. That is what we are going to study in this chapter. Now let us take the same experiment of tossing the coin. When we toss the coin, then there are only two possibilities. What are those? Either it will land with the head up or tail up. So the possibilities are two. That is the total possible outcomes in this experiment of tossing the coin is 2. Once you toss the coin, the total possible outcomes are 2. Now in this experiment, if I want to get head up, then I can have only one such outcome in one toss, because when I toss, either head can come up or tail. So in one toss, I can have only one such outcome of head coming up, and we will have one more outcome of getting a tail. We are assuming that all these kind of experiments will have equally likely outcomes. Now in such a case, the theoretical probability of an event, here when I say my favorable outcome is head up, then that is an event. So theoretical probability of an event of getting head, here it is the number of favorable outcomes divided by number of possible outcomes. Now in this case, when I want to get a head, the probability of this event, that is getting head, is number of favorable outcomes, it's only 1, and total outcomes we said it is 2. So the probability is half, that is 0.5, and the probability, theoretical probability of getting tail is also half. Now let us extend this experiment to a die. You know, die has got 6 faces. On each face, a number is written from 1 to 6. All 6 faces will have 6 different numbers from 1 to 6. When you throw the die, any one face can come up. Any one face. It can be 1, 2, 3, 4. Any one of the numbers can come up. Now the possibility of getting a specified number, suppose I want number 2 or number 3, any one of those numbers, then the possibility is only 1, unless I have written say 2 on all faces, then the possibility is more. But if I have written numbers 1 to 6 on these faces, and if I want number 1 to appear when I throw the die, then the possibility is only 1. So but there are totally 6 possibilities. That is either 1 can come up or 2, 3, 4, 5 and 6. So total possibilities are 6. But any one specified number I want, that possibility is only 1. So the probability of the event of getting 1 up is the favorable outcomes, that is 1, the total possible outcomes, that is 6. So this probability, you can say PE, or here I have written as P1, is 1 by 6. And probability of getting 2, that is also 1 by 6. Same thing, probability of getting 6, that is also 1 by 6. Such events having only one outcome of the experiment, they are known as elementary event. So the event of getting 1, that is an elementary event. Event of getting 2, that is an elementary event. Suppose I say the event of getting 1 or 2, that means I have 2 outcomes, that is not an elementary event. In an experiment, sum of all elementary events is always 1. Now here I have the possibility of getting 1, that is 1 by 6, 2, that is also 1 by 6. Like this, I have such 6 entries, so this becomes 6 by 6, that is 1. So the sum of all elementary events of an experiment is always 1. Now let us talk about complementary event. Again, let us take the example of throwing the die and the event is getting 1, that is the event. We know, suppose E is the event, the probability of getting 1, PE, is, we know it is 1 by 6. Now suppose one more event which says that not getting 1. When I say not getting 1, I can have either 2, 3, 4, 5 or 6. So the favorable outcomes are 5. So the answer, the probability of this event is 5 by 6. Usually we denote this as P E dash. E dash is not E. E dash is not E. So that is the probability of that event is 5 by 6. And always we have P E dash equal to 1 minus PE. Here PE is 1 by 6. So 1 minus 1 by 6 is this one, that is 5 by 6. The event E dash, this is E dash, representing always not E, that is E dash is always not E, is called the complement of E. So E dash is the complement of E, or we can say that E and E dash are complementary. If you know one, you can find out the other one by subtracting that from 1. Impossible event. Again the same experiment. The event here is the possibility of getting 7 when I throw a die. Seven is not there in the die at all. So we cannot get 7 at all. So the favorable outcomes is always 0. Total outcome here is 6. Therefore PE, the probability, theoretical probability is 0 divided by 6. It is 0. So such an event where the probability is always 0, such an event is known as impossible event. Now sure or certain event. We will take the same example of throwing die. Now what is the probability of getting number 1 to 6 when you throw a die. What is the probability? In this case, the favorable outcomes are 6. That is, even 1 comes up, or 2, 3, 4, 5, 6. Any one of these comes up, that is favorable. So total favorable outcomes is 6. Total possible outcomes is also 6. Therefore, the probability of the event of getting a number 1 to 6 when you throw a die is 6 by 6, that is 1. So when the probability is 1, such an event is known as a sure or certain event. The probability value range, we know for a impossible event the probability is P is 0. For a sure event PE is 1, and we know by definition PE equal to number of favorable outcomes divided by number of all possible outcomes. Number of favorable outcomes divided by number of all possible outcomes. So number of favorable outcomes will always be less than the total number of possible outcomes. When number of favorable outcomes is 0, then PE value will be 0. When number of favorable outcomes is equal to the total number of possible outcomes, then PE value will be 1. In all other cases where number of favorable outcomes is greater than 0 and number of favorable outcomes is less than number of all possible outcomes, PE value will be greater than 0 and less than 1. So PE value will be always less than or equal to 1 and greater than or equal to 0. So P value has to be within these limits, and it can never be more than 1 and it can never be less than 0, that is negative. Probability cannot be negative, probability cannot be more than 1. Now we will solve a few problems. First one, which of the following experiments have equally likely outcomes? Explain. First one, driver attempts to start a car. The car starts or does not start. This does not have equally likely outcome because most of the time car will start. Second one, a player attempts to shoot a basketball. He or she shoots or misses the shot. So this also it does not have equally likely outcomes, because if the player is not at all good, he or she may always miss. If the player is good, he or she may always shoot it. So it depends upon the player. So the event does not have equally likely outcomes. Third one, a trial is made to answer a true or false question. The answer is right or wrong. Yes, this is correct. This has got equally likely chances because there are two possibilities, either it is true or false. Fourth one, a baby is born and it's a boy or girl. This is also equally likely outcome. It has to be either a boy or a girl and both have got equal chances. Second one, which of the following cannot be the probability of an event? This is 2 by 3. 2 by 3 minus 1.5, 15% and 0.7. We said PE will be less than or equal to 1 and greater than or equal to 0. It has to be between 0 and 1. So 2 by 3, this is between 0 1, it is possible. Minus 1.5, this is not possible. 15% can be written as 15 divided by 100 is equal to 0.15. So this is possible. This is 0.7. This is also possible. If probability of an event is equal to 0.05, what is the probability of not E? We said not E, that is the probability of not E equal to 1 minus probability of the event, that is 1 minus 0.05, that is 0.95. This is the probability of not E. A bag contains 3 red balls and 5 black balls. A ball is drawn at random from the bag. What is the probability that the ball drawn is red? The bag has 3 red balls and 5 black balls, totally 8 balls. So when you draw one ball at random, that can be any one of these 8 balls, so you have 8 possible outcomes. Now first one, it has to be red. Red means how many red balls are there? There is 3. So in this case, favorable outcomes, that is 3. Therefore, the probability of this event, that is you drawing a red ball, is the favorable outcomes, that is 3 divided by the total possible outcomes, that is 8. This is the answer. Now second one, not red. Not red, you know, we can P E dash is 1 minus PE. Just now we talked about this one. So it is 1 minus 3 by 8 equal to 5 by 8. This is one way of finding it out. The other way is not red means it has to be black. How many balls are there? 5 black balls. So if it is not red, you will be getting one of the black balls, that is 5 favorable outcomes divided by the total number of possible outcomes. So the probability of that event is 5 by 8. You can calculate using either of this method. This is the simpler method. A piggy bank contains 100 50 paise coins, 100 50 paise coins, 50 1 rupee coins, 20 2 rupees coins, and 10 5 rupees coins. 10 5 rupees coins. If it is equally likely that one of the coins will fall out when the bank is turned upside down, what is the probability that the coin will be 50 paise coin? That is the first one here. Let us find out the first. Let us first find out the total possibilities. Total possibilities is the sum of this one. So any one of the coin can fall. So there are how many coins here? 180. So any one of the 180 coins can fall. So this is the total possible outcomes. Now the first one will be 50 paise coin. That is, now PE, the event is a 50 paise coin, that is equal to the favorable outcomes. What are the favorable outcomes? 50 paise coin falling, that is how many are there? There are 150 paise coins. So any one of these coins can fall. So favorable outcomes is 100 divided by the total possible outcomes is 180. So the answer is, this is 5, this is 9. So 5 by 9. Second one, will not be a 5 rupee coin. Will not be 5 rupee coin means not this. It can be any one of these. So what is the possibility? You have how many? 100 plus 70. 170 coins. Any one of these can fall. Therefore, the probability of this event equal to favorable outcomes 170, total possible outcomes 180, zeros cancel. The answer is 17 by 18. This is the possibility of a coin other than the 5 rupee coin falling down. A die is thrown once. Find the probability of getting a prime number. A number lying between 2 and 6. Third is an odd number. First one. Now before that, a die is thrown once. Therefore, total possible outcomes can be any one of the side. So it is 6. Either one can come up or 2, 3 up to 6. Now let us take the first one. A prime number. So which are the prime numbers in this? From 1 to 6, 2 is a prime number, 3 is a prime number, 5 is a prime number. Therefore, probability of this event is favorable outcomes, that is 3, divided by the total possible outcomes, that is 6. So answer is half. Second one. A number lying between 2 and 6. A number lying between 2 and 6. 2 and 6 are not included. What are the other numbers included? 3, 4 and 5. 3 numbers. So here also PE, probability of this event, equal to 3 divided by 6 equal to half. Third one. Third one is an odd number. Which are the odd numbers? 1, 3, 5. Here too, favorable outcomes are 3 divided by total possible outcome 6. Answer is half in this case too. Seventh problem. In this case, a die is thrown twice. This is not die 1 and die 2. This is I will say throw 1, throw 2. A die is thrown twice. What is the probability that 1, 5 will not come up either time. Second, 5 will come up at least once. Third, sum of two numbers appearing on the top is 8. Fourth one, sum of the two numbers appearing on top is less than or equal to 12. Let us take the first one. Now before that, let me explain this table. When a die is thrown twice, so you can have first time 1, second time also 1, or first time 1, second time 2, or here first time 2, second time 1. So there can be totally so many possibilities. So there are totally 36 different combinations. So the total possible outcomes when a die is thrown two times, a die is thrown 2 times, or 2 dice are thrown at the same time, both are same, the total possible outcomes is 36. Now let us take the first part. 5 will not come up either time. Where do you have 5? 5 you have here in this case. Then you have 5 here. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is counted 11. So 11 times 5 appears. But what here it says is 5 will not come up. That is 36 minus 11. So PE of 1, the probability of the event is the Favorable outcomes are all the outcomes other than what I have marked here. So that is 36 minus 11 divided by total possible outcomes, that is 36. Answer is 25 divided by 36. 5 will come up at least once. These are the ones I have marked. So in all these cases 5 is there at least once. In this case it is 2 times. The answer for this is the favorable outcomes in this case are 11. Total outcomes are 36. Answer is 11 by 36. Third one. It says sum of two numbers appearing on the top is 8. 1 plus 1, 2. So from where it starts? 1. Yeah, here. 2, 6, that is 8. Same way 3, 5 is 8, 4, 4 is 8, 5, 3 is 8, 6, 2 is 8. So this entire region, this portion satisfies the condition. So 2, 6, 3, 5, 4, 4, 5, 3 and 6, 2. 1, 2, 3, 4, 5. So the favorable outcomes are only 5 here out of the 36. So probability of getting this event favorable is 5 divided by 36. The last one. Sum of two numbers appearing on top is less than or equal to 12. If you sum up the two numbers appearing in each cell, then everywhere it is less than 12. The last one is 6, 6, that is 12, but it says less than or equal to. So every cell conforms to this requirement. That means total favorable outcomes are 36, total outcomes are 36. In that case, the probability of the event is 36 divided by 36, that is equal to 1. When you have this kind of problem, either a die is thrown twice or two dice are thrown simultaneously. First, what you need to do is prepare a table like this and then answer the questions. Without that, it is very difficult to solve this kind of problems. So take care that you draw this table first and then solve the problem. Eighth one. One card is drawn from a well shuffled deck of 52 cards. Find the probability of getting, first one, a king of red color. I hope you know about the 52 cards in a deck. If you do not know, then it's better to take a set of cards, go through that and find out how many colors are there, what type of cards. Then you can answer these questions, otherwise not. Let us take the first one. A king of red color. There are 4 kings in the set, but red color are only diamond and hearts. So you have 2 favorable outcomes here, that is king of red, king of diamond and king of hearts, and you are drawing from a pack of or deck of 52 cards. So total possible outcomes is 52. The answer is 1 by 26. Second one, a face card. A face card is where you have a face. King, queen and jack. These are the 3 cards having the face. So 3 into 4 you have spade, clubs, diamond and hearts. So 4 into 3, so 12. So you have 12 face cards. So probability of this event is 4 divided by 52. Sorry, 4 into 2, that is 12 divided by 52, 4, 3 times 13. The answer is 3 by 13. This is the probability of getting a face card while you draw from a deck of 52 cards. Third one. A red face card. A red face card. Red means only diamond and hearts. Total you have 6 face cards in red. Probability of this event is favorable outcomes are 6 divided by 52. So this will be 3 and 26. 3 by 26 is the answer for this. Fourth one, a jack of hearts. Every group will have only one jack, that is spade, clubs, hearts and diamonds. Here it is specified the jack of hearts. That means there is only one card, one jack of hearts. Out of the 52 cards, favorable outcomes are 1 and total outcomes are 52. This is the probability. Fifth one, a spade. There are 4 different types of cards: spade, clubs, diamonds and hearts. Each has got 13 cards. So when you draw one card at random, it can be any one of the 13 cards. So favorable outcomes here are 13. The total possible outcomes are 52. So the answer here is 1 by 4. The last one says Queen of Diamonds. Queen of Diamonds. There is only one Queen of Diamonds in the entire set. There are 4 queens belonging to different type of cards, but diamond, Queen of Diamond is only one. So the probability is 1 divided by 52. Ninth problem. A lot of 20 bulbs contain 4 defective ones. That means you have got total bulbs is equal to 20. Good one are 16. Defective are 4. Let us try to understand the problem. One bulb is drawn at random from the lot. What is the probability that this bulb is defective? The first one, in this event, what is the probability that this bulb is defective? How many defective bulbs are there? 4. That means the favorable outcomes are 4. But there are totally 20 bulbs. So total possible outcomes are 20. So 4 ones are 5. So the probability of getting a defective bulb is 1 by 5. Suppose the bulb drawn in 1 is not defective and is not replaced. Now one bulb is drawn drawn at random from the rest. What is the probability that this bulb is not defective? Now one bulb is drawn in this experiment and it is not defective. It is a good bulb, but it is not replaced. You are not going to put back in the lot. So initially there were 16 good bulbs. Now there are good bulbs, that is 50. Now one less. We took one that is good one and we didn't put it back. But defective are still 4 because we have not touched that. So we have now 15 good bulbs and 4 defective bulbs. So total you have 19 bulbs. Now one bulb is drawn at random from the rest. That means from the 19 bulbs. What is the probability that this bulb is not defective? That means this bulb is good. So favorable outcomes are 15, total outcomes are 19. So probability of this event is favorable outcomes 15 divided by total outcomes 19. This is the answer. when the bulb is not replaced, then you have to deduct it from the good bulbs and as well as the total, and then you need to calculate the probability of the event. 10th problem, a box contains 90 discs which are numbered from 1 to 90. If one disc is drawn at random from the box, find the probability that it bears a 2-digit number, a perfect square number, and a number divisible by 5. They have given it contains 90 discs and you are drawing a disc at random. So the total possible outcomes, it can be any one disc, so total possible outcomes are 90. Now let us take the first one. It is a 2-digit number. 2-digit number starts from 10. So you have 10 to 19, 10 numbers, then 20 to 29, another 10 numbers. Like this up to 89, you have 8 sets of such numbers. So you have 10 into 8, then you have the number 90. So you have 81 2-digit numbers. Starting from 10 up to 90, you have 81 2-digit numbers. Or another way of calculating is 90 minus 10 and then add 1 to that becomes 81. Now this is the favorable outcome number. So probability of this event, that is the disc that what you have randomly drawn is a 2-digit number, is number of favorable outcomes 81 divided by total outcomes 9 9s are 9 10s are, that is 9 by 10. The first one. Now second one. Second one, it says a perfect square number. Perfect square, 1 is perfect square, 4, 9, 16, 25, 36, 49, 64, 81. So you have 9 numbers. This is the favorable outcome. So probability of this event is favorable outcomes, that is 9, total outcomes, that is 90. So answer is 1 by 10. Third one, a number divisible by 5. So from 1 to 10 you have 2 such numbers, into up to 90 you have such 9 sets. Totally you have 18 numbers which are divisible by 5 in the lot of 1 to 90. So this is the favorable outcome. Favorable outcomes. Therefore the probability of the event that the number that what the disc that what we have drawn as the number which is divisible by 5 is 18 divided by 90. 18 ones are 18 5s are, answer is 1 by 5. 11th one, Rajesh tosses 2 coins simultaneously together. What is the probability that he gets at least one head, at most one tail? It tosses 2 coins. So let us find out the possible outcomes, total possible outcomes. First coin is head, second coin is shows tail, or first coin shows head, second coin also shows head. Third one, first coin shows tail, second one is head, or both are tail. These are the 4 possible outcomes. So total outcomes here is equal to 4. Now let us try to answer the question. At least one head. You must have at least one head. So here one head is there. Here also one head. Two heads are there, but it says at least one head. This is also a favorable outcome. This is also favorable outcome, but not this because there is no head here. So total outcomes is 4. Now for this question number 1, favorable outcomes that is equal to 3. Therefore probability of the event is equal to 3 by 4. Second one, at most one tail. At most one tail. It cannot be more than one tail. Here it is one tail. This is okay. Here is no tail. This is also okay. What it says is you can have maximum one tail, but no tail is also okay. So this is also favorable outcome. This is also one tail. Here two tails. So this is, in this case also, these are the 3 favorable outcomes. Therefore in this case also the probability of the event is 3 divided by 4. I think we are going to have the last one. A game consists of tossing 1 rupee coin 3 times and noting its outcome each time. Hanif wins if all the tosses give the same result, that is 3 heads or 3 tails, and loses otherwise. Calculate the probability that Hanif will lose the game. He will win only if he gets all 3 heads or all 3 tails. Now in the earlier problem we said when we toss 2 coins, it can be the first coin head and second coin tail, or first coin head or second coin also head, or first coin tail or second coin head, and last one is both the coins showing tail. These are the 4 options. Now if you have one more coin, then it is simple to calculate the total possible outcomes. You copy this one once again here, and last one is TT. Now in this case the first coin can be head. You put head everywhere. Then in this case it is, so when you toss 3 coins, the total possible outcomes are 8. Therefore total possible outcomes equal to 8. This is the simplest method to do. First take 2 coins, find out the 4 possible outcomes, copy it again, and in front of one set add head, in front of the other set add tail. This is the simplest form of calculating the possible outcomes when you toss 3 coins. Now total possible outcomes is now 8. Now he wins if he gets 3 heads or this tail, I copied wrong, TT, or he gets all 3 tails. In all the other cases he loses. So it's 1, 2, 3, 4, 5, 6. So in all these cases he loses. That means calculate the probability that Honey will lose the game. So the favorable outcomes here. Favorable outcomes are 6, due to which Hanif will lose. Therefore, the probability of the event, probability of Hanif losing the game is Favorable outcomes 6 divided by total outcomes 8 is 3 times 4 times 3 by 4. This is the last problem. I have tried to cover here most of the generally asked problems, and if you are thorough with this, I think you will be in a position to answer any question in this chapter probability.